Alright guys, you know who it is. It is Coach Goo, and we are back with another fun-filled, action-packed, flipped geometry classroom video. This time, we're going to be learning the postulates and theorems for parallel lines so we can use them in proofs. In what? In proofs. Not proof. Yes, proofs. We're going to be doing proofs. So all of these, check this out. All of these postulates and theorems and properties we're going to be using in proofs. But the good thing is you've already learned all of these rules, but now you just attach the word postulate or theorem onto them. Okay, so I'm going to quickly go over the definitions because we've already learned these once, and I'll show you some examples. So let's get into it. Let me zoom it in a little bit. Okay, there we go. All right, the first one right here is corresponding angles postulate. Remember, a corresponding angle, the postulate for corresponding angles, which means the special rule we can use, is if we have two parallel lines, so these are parallel, and I'm going to mark them with my special parallel line symbol, and then they are cut by a transversal, then corresponding angles are congruent. Remember, corresponding angles means, for example, look at this. If these two parallel lines are cut by this transversal, if we were to number them, look, 1, 2, 3, 4, then the other one would have the exact same 1, 2, 3, 4. Then corresponding angles would be 1 and 1, 2 and 2, 4 and 4, 3 and 3. So those would all be congruent, the ones that are corresponding. So look, 1 and 1, congruent. 2 and 2 would be congruent. 3 and 3 would be congruent. 4 and 4 would be congruent. So you can use this rule, and when you use this rule in a proof, you're going to write corresponding angles postulate. All right, let's go to the next one. The alternate interior angles theorem. Let me draw a little picture here. So if two parallel lines, once again, maybe it doesn't look parallel, but now it is because of my label, are cut by a transversal. Here's the transversal. Then alternate interior angles are congruent. Now, where are the alternate interior angles here in this picture that I have so nicely drawn? The alternate, remember, they're interior, so it's in between or inside the two parallel lines, and they're alternate, so that would be like this. I'm gonna use different colors. The orange one, look, right here, boom, those are alternate interior angles. And these two would be congruent because these two lines are parallel. And where's the other pair of alternate interior angles? Right here, boom and boom. And those two are parallel as well. So that is the next one, the alternate interior angles theorem. Make sure you write that one when you use this rule in a proof. Let's go to the next one. Now we have the alternate exterior angles theorem. So let me draw another picture. I'm going to change it up because I'm running out of space here. If two parallel lines are cut by a transversal, here's my transversal, then alternate exterior angles are, once again, what do you think? Congruent. That's right, boys and girls, congruent. Where are the alternate exterior angles? They're exterior, so they're on the outside of the two parallel lines, and they're alternate. So one would be right here. There's one pair of alternate exterior angles. These two would be congruent, and then my other pair would be right here. Boom and boom, and those two would be congruent as well. All right? So that is going to be the alternate exterior angles theorem. All right, let's move it down. On to the next one. I'm just going to scroll all the way down to here. There we go. Now we're going to go on to the same side interior angles theorem. So once again, if two parallel lines are cut by a transversal, here's my parallel lines. They're parallel, and they're cut by a transversal. Then same side interior angles are, what do you think? They're not congruent this time. They're supplementary. And what does that mean? That means they add to 180 degrees. That's supplementary. Okay, so where are the same side interior angles. First of all, it's interior, so it's in between the two parallel lines, and they're same side, so it's on the same side of the transversal, which means on the interior would be right here. Boom. Those would be one pair of same side interior angles, and the other pair would be right here. They're the same side of the transversal, and then they are on the interior of the two parallel lines. And these two would add up to be 180 degrees. So for example, if I were to label, you know, this 1 and 2 and this 3 and 4, then the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Also, the measure of angle 3 plus the measure of angle 4 equals 180 degrees. That's right. Okay, let's go to the next one, linear pair theorem. And all this one says is that linear pairs are, let me write it in, are supplementary. So linear pairs, for example, if you got a little line going over here, boom, and then you have a linear pair. That means two angles that add up to make a line. So like this. Then we've got angle 1 and angle 2. And as you can see, they add up to create this line. This line, see, they add up to be this whole line. And that means they would add together, if I were to label them angle 1 and angle 2, then the measure of angle 1 plus the measure of angle 2 equals 180 degrees. All right, and on to the last one in this box. Vertical angles are, what is this one? Remember, vertical angles look like this. We've got two intersecting lines. Vertical angles are the ones that are directly across from each other. So for example, like this, boom, those two. And then we've got, boom, those two. So if I were to label them with numbers, angle 1, 2, 3, and 4, which pairs are vertical? Remember, it would be 1 and 3 and 2 and 4. And vertical angles are, what's the rule about this one? Look in your old notes. If it is congruent, they're congruent. So if I wanted to finish labeling this picture, I would draw this congruent. Boom. And then bam. There we go. Now on to the last one. These are some properties. We've been using these ones already. So substitution property of equality. If the measure of angle A plus the measure of angle B, let me just label these with some colors. If the measure of angle A plus the measure of angle B equals 180, and the measure of angle A, this is pink one, equals the measure of angle C, then I can replace the measure of angle A with the measure of angle C. So instead of writing measure of angle A, I'm going to write measure of angle C plus the measure of angle B equals 180. All I did was substitute right there. So that is the substitution property of equality. We've already used this many a time. So let's go on to the next one. Transitive property of congruence. So if angle A, look, we've got a transitive property of congruence now. If angle A is congruent to angle B, and angle B is congruent to angle C, where's my other color? Then angle A is congruent to which one do you think? Angle C, that's right. So there is the final property that we're gonna use on these parallel line proofs, okay? Let's go ahead and try some of these parallel line proofs examples together. Number 1. So remember, on these proofs, you know, you must look at the picture. They give you the picture for a reason. I know some of you guys like to ignore the picture, but you got to use the picture, all right, and label. The first thing you want to do is label. So let's take a look at the given. They say A is congruent to B. Line A is congruent to B. A is parallel to B. So let's label that first. Where's A? Here's A, and here's B. So these two are parallel. So I'm gonna draw the symbol, boom, and boom. Then it says L is parallel to M. So let me label that one as well with the double. All right, so we've got those two, and they want us to prove, let's just take a look at what they want us to prove. They want us to prove that angle 1, that's right here, is congruent to angle 12, that's right here. So, how are we going to prove that angle 1 is congruent to angle 12? They gave you some hints in the statements, so let's get at this. First, what's going to go in the very first blank? Remember, the first blank is always the given, so I'm going to go ahead and write A is parallel to B, and L is parallel to M. Okay, I should probably make this a cursive one so you can see. All right, there it is, and the reason is it is given. All right, next step, they're telling us that angle 1 is congruent to something. Angle 1 is congruent to, I already marked it on here for you, angle 5. Look at that. Now, how are these two congruent? How are these two congruent? They are congruent by angle 5, and then it's congruent by the corresponding angles postulate. Remember, look at the top of the notes. That says corresponding angles when there are parallel lines are congruent. Therefore, 1 and 5 are congruent. Next, they're telling us that something is congruent to angle 12. Which one is congruent to angle 12? Well, right here, angle 5 is congruent to angle 12. And how did we get that? How do we see that angle 5 right here is congruent to angle 12 right here? Take a look at your notes, your definitions, and see which one it is. It would be the alternate exterior angles theorem. The alternate exterior angles theorem. And how do we know that? Because look, 5 and 12 are on the exterior of L and M, which are parallel, and they're alternating on alternate sides of the transversal. So they are alternate exterior angles. Because L and M are parallel, that means they are congruent. And now our final step, what always goes in the last step? It's always going to be the prove. So this prove is going to go straight here. I'm going to say angle 1 is congruent to angle 12. And how do we get that angle 1 is congruent to angle 12? Well, if you see, look right here, angle 1 is congruent to angle 5. 5 is congruent to 12, which means that 1 is congruent to 12. And that is the transitive property of congruence. It's exactly written like that in the notes right above. So that is the end of this parallel lines proof. Yippee! On to the next one, number 2. All right, so what's the first thing that we're going to do? Label. So A is parallel to B. So A and B, that's right here. And L is parallel to M. So that means there we go. Okay, and they want us to prove that angle 16, that is right here, is congruent to angle 6, that is right here. All right, and then we have 4 boxes, and we're going to need 4 reasons. So, in the first box, what are we going to write? It's always going to be the given. So, A is parallel to B, and L is parallel to M, and that is given. Let's go ahead and write our last statement. 1, 2, 3, 4. Last statement is going to be angle 16 is congruent to angle 6. All right, so let's get started. First of all, remember we're going to have to be dealing with 16 and 6. So let's just start with 16 because that's the first thing that was given. So let's take a look and see if 16 is congruent to anything else on here. 16 is congruent to 11. Boom. So let's write that 16. Angle 16 is congruent to angle 11. And how do we get that? That is once again the corresponding angles postulate. This is not an L, that's an angle, okay? That's an angle. Corresponding angles postulate. There we go. All right. Now we've used 11. Let's see if 11 is congruent to anything. 11 is congruent to angle 6. Wow, look at that. Angle 11 is congruent to angle 6. And how do I know that? That is because 11 and 6 are alternate. Whoa, they are alternate exterior angles on these parallel lines, which means by the alternate exterior angles theorem, they are congruent to each other. And then our final step, look, in step 2, 16 is congruent to angle 11. In step 3, angle 11 is congruent to angle 6. And suddenly, in step 4, we have angle 16 is congruent to angle 6, which means once again, we've used the transitive property. Transitive property of congruence. Do not write of equality this time because we're dealing with congruent signs. As you can see, from beginning to end, we only use congruent signs. So make sure you write transitive property of congruence. And that's the end of number 2. And number 3, it doesn't say it on your paper, but number 3 is actually going to be a you try. Oh boy. Try this one on your own. We're going to check it in class the following day with your teacher. And then that's going to be the end of this video. So see you in the next one. Peace.